You must be wondering about what is on the screen, really. Well, you are not the only one wondering. I'm also wondering. But to tell you the truth, what we are having on our screen now is those two diagrams that are trying to show us the knee joint. That is a joint, specifically the knee joint. And it is those two bones that are being joined at the knee joint. But it is so fascinating in that we can't see actually those surfaces of those two bones which come at the place of articulation, but rather those points, those ends of those two bones that are articulating have been covered in that whitish material that we are seeing. That whitish material that we are seeing is a covering of those two bones. And that covering, that whitish material, is known as cartilage. And specifically the cartilage at points of articulation, especially in synovial joints, we call it the articular cartilage. And so it is our purpose now in this video to learn and to know more about this cartilage, to learn more about cartilage. And this is a walkover, is it? Because from our previous studies, remember, we found that this cartilage is but a connective tissue. We also found out that not only is it a connective tissue, but a specialized kind of connective tissue. As a matter of fact, we saw that cartilage is in 3 types. All right? Yes, based on its ECM and cells proportion. And at those 3 types, we discovered that we have hyaline cartilage, we also have fibrocartilage, we also have elastic cartilage. We also, through our previous lessons on joints, found out that cartilage is distributed also at some joints. All right? As a matter of fact, we are seeing here at a joint it having been distributed in this kind of a joint, which is the knee joint. All right? And again, as a matter of fact, we also found it covering the ends of long bones, as it is doing here at the knee joint, covering those 2 long bones, the femur and the tibia. All right? We also, important to note, is that cartilage also guides the development and growth of long bones before and even after birth. But what really is this cartilage? All right? Now, you will discover that cartilage is some material that is so tough. That thing, that whitish thing, material you are seeing covering those 2 bones is somewhat tough. It's tough, but also flexible, but durable. So, in other words, cartilage is but a tough, durable form of specialized connective tissue. All right? It has a firm consistency. That is, its toughness. Its toughness is uniform at each and every point in its structure. That is to say, how hard it is at one point is how hard it is at every point. All right? So, this white structure, this cartilage that we are seeing, it is a tough material, but its toughness is the same throughout its structure. So its firmness is so consistent. All right? And this consistency is what allows it to bear mechanical stresses without distortion. All right? So because its toughness, its hardness at each and is the same at each and every point, so it may not be distorted in its structure. It's able to face any mechanical stresses without any distortion because how hard it is at one point is the same as how hard it is at every point. So cartilage, we said it is a connective tissue, is it? Alright, and what do we know about all connective tissues? We know that all connective tissues, their ECM, their extracellular matrix is so abundant. They have more of ECM than of cells, and that is same also with the cartilage. Just like any other connective tissue, it also consists of cells and ECM, but ECM is in abundance. Alright? This abundant ECM is highly concentrated with glycosaminoglycans and proteoglycans. Alright? What do we know about glycosaminoglycans and proteoglycans? Glycosaminoglycans and proteoglycans are but materials, substances, macromolecules which make up the ground substance of the ECM. So we are saying actually that for cartilage, much of its ECM is highly concentrated with glycosaminoglycans and also with proteoglycans, those ground substances, right? And remember, we also in the ECM, yes, there are protein fibers in the ECM. And to be specific, the unique kind of protein fiber among the collagens that is found in the cartilage is type 2 collagen. Alright, and we also have elastic fibers in there. And so the collagen type 2 and the elastic fibers, they are found to be interacting with these glycosaminoglycans and these proteoglycans, which are so highly concentrated. Right? Another substance of importance to note in the ECM of a cartilage is hyaluronan. Alright? And now, actually, the physical properties of the cartilage will depend on the interactions between these structures of the ECM that we have mentioned up here. The type 2 collagens and the glycosaminoglycans and the proteoglycans, together with also those hyaluronan. So the interactions, what happens is that in the cartilage, alright, you'd find that type 2 collagen, alright, will form some electrostatic bonds with the hyaluronan, alright, and also you'd find that proteoglycans and the glycosaminoglycans, they form also some electrostatic bonds. Alright, now it is on these kinds of bonds, the electrostatic bonds between the glycosaminoglycans and also these electrostatic bonds between the type 2 collagen and the hyaluronan, is that on these kinds of bonds, it is on these bonds on which the physical properties of our cartilage actually lies on. All right, is what these are the bonds which give our cartilage its physical properties. Also important to note in the ECM of our cartilage is the presence of water. There is water actually again in the ECM of our cartilage, and this water is found again to be forming some good electrostatic bonds between those glycosaminoglycans that are bound to the proteoglycans, and these waters also form some electrostatic bonds with those hyaluronan which are bound to the type 2 collagens. And having formed those bonds, now this water will be found enclosed in a meshwork of type 2 collagen. And now, at the end of it all, what we are now getting to realize actually is that in cartilage, there is a good amount of water that is bound in there. And it is this water which actually makes cartilage to act as a shock absorber. And also important to note, friend, is that our cartilage, all types of cartilage actually, they are surrounded. It is surrounded by a dense connective tissue, known as perichondrium. But except for that cartilage, which is found at points, at joints, just like this cartilage on the screen, that one is not surrounded by perichondrium, but all other cartilages are all surrounded by a perichondrium. And why should a perichondrium surround them? Well, we must have it in our minds, understand it, and keep it in our minds that cartilage is avascular. Cartilage has got no blood vessels, so it has got no direct supply of nutrients and oxygen. Alright? How does it now obtain its nutrients? It obtains them through that perichondrium which is surrounding it. Through that perichondrium, that dense connective tissue. That perichondrium is vascular, has got blood vessels. So the nutrients, they do diffuse off from that same perichondrium into the cartilage. That's how we know cartilage is supplied with nutrients and oxygen. But how come, therefore, if this one on the screen, which is the cartilage that is usually found at joints, doesn't have perichondrium surrounding it, but how then does it find its supply of nutrients? Well, remember, usually articular cartilage, which is this cartilage here, it is usually found at synovial joints, and so it finds its nutrient supply through the synovial cavity. From the synovial fluid that is in the synovial cavity, nutrients, they do diffuse from there and supply this articular cartilage. So that is very, very important as well to know. Also important to note is that all types of cartilage, they are not innervated. They lack nerves. And as we noted earlier, that there is, a difference, right, in the distribution of ECM among cartilage that is found in our body. And that is what actually has led to the classification of our cartilage into 3 types of cartilage: hyaline cartilage, elastic cartilage, and fibrocartilage. So we will do well, therefore, to discuss about each of them. So let's now get to discuss about each of these types of cartilage. But before we get to these various types of cartilage, it is also of importance to note that in cartilage there is only one cell type which is embedded in the ECM, and that one cell type found in cartilage are known as chondrocytes. So the chondrocytes are the ones that actually synthesize the ECM and maintains its components, and they are found in ECM vesicles, which we call the lacunae. So let's now get to learn about those 3 types of cartilage. And now specifically, we'll start with the first kind of cartilage, which is known as hyaline cartilage. Alright? Hyaline cartilage, what should we know? It is important, friends, to note that hyaline cartilage is the most common type of cartilage in the human body. Alright? When this hyaline cartilage, it is still fresh, just like we saw it in that previous diagram at that knee joint. That is hyaline cartilage, remember? Alright? So when it is still fresh, that hyaline cartilage, it appears homogeneous. That is to mean that it appears the same throughout its structure. And not only does it appear homogeneous, but also when it is still fresh, it is also semi-transparent. That That is, it is partially transparent. That is, it can be partially be seen through. Alright, so it is not really a thick, but it is a thin plate. Alright, which can be partially be seen through. When it is still fresh, hyaline cartilage has a shiny white semi-transparent appearance. As you saw it in that picture, actually, it appeared to be a shiny white semi-transparent structure. So that's the appearance of our hyaline cartilage. All right. Now, how is the matrix of the hyaline cartilage? All right. We must understand that the matrix of the hyaline cartilage, all right, its ground substance is highly concentrated with hydrated proteoglycans and glycosaminoglycans. In other words, I'm saying much content of its ground substance is proteoglycans and glycosaminoglycans. All right, and the specific kind of the proteoglycan which is so abundant in the ground substance of the matrix of the hyaline cartilage is known as aggregans. So aggregan is a proteoglycan actually that is so unique and specific to cartilage, and hence sometimes actually it is also called cartilage specific proteoglycan. All right. Now, this proteoglycan appears to have in its structure several chains of glycosaminoglycans, and the specific kind of glycosaminoglycans that appear in its structure are chondroitins and also keratan sulfates. So we have glycosaminoglycans. Glycosaminoglycans are in types. We have chondroitin sulfate. We also have keratan sulfates. All right. Now, in the proteoglycan known as aggregan, in its structure, it has got chains of glycosaminoglycans, and the specific type of glycosaminoglycans that appear in its structure are chondroitin sulfate and keratan sulfate. A glycoprotein which is of importance now in the hyaline cartilage matrix is chondronectin. Chondronectin is a mount-adhesive glycoprotein which facilitates that the cells of the hyaline cartilage are strongly adhered with the ECM. The other structure in the ECM which is of importance to note is the protein fibers, and the kind of a protein fiber which is so abundant again in hyaline cartilage is collagen type 2. Hence in summary, we are trying to say that in the ECM of hyaline cartilage, the structures that are so abundant in there, or what makes up much of the ECM, is actually type 2 collagen fibers and also the proteoglycans. Now, the ECM of hyaline cartilage, all right, try to actually just, look at this very structure on the screen and concentrate your eyes now on the ECM. You know the ECM, right? Yeah, so that ECM actually, as you can see it, this ECM of hyaline cartilage has local differentiations in molecular compositions. What I'm now trying to tell you is that the amount of molecules at one area is not the same amount of molecules at another area. For example, right, we have two kinds of areas in the hyaline cartilage matrix, all right? We have that area which is just immediately to the cells. That area just immediately to the cells. That area is called the territorial ECM. And then there is that area in the ECM, but further away from cells. It is called the interterritorial ECM. All right. Now, when you consider those two areas, there is a variation in a way in which they have been stained. All right. When you look at the staining, there is a variation in which those two areas that we have mentioned have been stained. For example, the territorial ECM appears to be deeply stained, and this simply is because that the area has much of macromolecules, has much of glycosaminoglycans than of type 2 collagens. So more of ground substance than protein fibers. The territorial ECM, that space just immediately surrounding the cells, as you can see now in those diagrams, the territory appears to have been deeply stained. That is simply because it has got much of glycosaminoglycans than it has of type 2 collagen. Right? But the interterritorial ECM, it appears pale. Alright? It appears pale. It is not deeply stained simply because it has much of protein fibers than of type 2 collagen, and than of glycosaminoglycans. All right. So hence, what we are seeing now is that there is a variation in staining, and this variation in staining is telling us that there is a local difference in molecular composition in the ECM of the hyaline cartilage. Now, what about the cells that make up the hyaline cartilage? Alright, now, as we know it for every kind of cartilage, that the kind of cells that we can just find in there are chondrocytes. And you are right. The major cells found in cartilage is chondroblast cells and chondrocytes. Alright? The chondroblast cells are immature cells. Wow! Chondrocytes are matured and are the ones actually that produced the ECM and its constituents. This ECM that we are seeing surrounding those cells was actually produced by those very cells, those chondrocyte cells. Alright? And now, when you look at the periphery, especially on those two above diagrams, alright, at the margins, at the periphery, that is at the margin, and that is to mean at the edges, which is at the ends of the hyaline cartilage that we are seeing in those two diagrams which are above. Alright, you'd find that the chondroblast cells appear elliptic shaped. To be elliptical or to be elliptically shaped, we are meaning that they appear stretched into an oval shape. So we are saying those cells at the periphery, at the ends, at the margins of the hyaline cartilage, they appear to be oval shaped. But at the center, they are deep, or at the deep center, right? In the hyaline cartilage, they are rounded cells. They appear to be so rounded cells, as you can see. All right, they appear to be so rounded. All right, and they appear in groups, especially in that above diagram, but at the left side, at the right side. You'd see that there are those cells at the center, those cells, those chondrocytes, chondroblast cells, they appear to be rounded, but they appear to be in groups. And often, sometimes there are groups of 8. And it is so fascinating to know how these groups came about. Alright? So what really happened is that a single cell, a chondroblast, went through mitotic cell division, and it produced all these cells in that single group. Alright? So what really happened, a single cell went through mitotic division and resulted into the cells, many cells, which now we are making a group of cells. So those two individual groups of cells, we are actually due to a single a single chondroblast in those individual groups to undergo mitotic division, and it gave rise now to those other cells which make up now a group. Each group had a single chondroblast which underwent mitotic division and produced now all those other cells. Now, because these groups are but groups of cells where the cells making up a group came from the same origin or originates from the same cell, these groups of cells are called isogenous aggregates. So those are isogenous aggregates. So we have, like, especially in the right diagram on the above two diagrams, that right diagram, we are actually able to view those isogenous aggregates. So those isogenous aggregates, those cells in each isogenous aggregate, where actually they all come from the same cell which underwent mitotic cell division. All right, so that's it. They appear into isogenous aggregates, that is, groups of cells which have the same origin, cell mitotic origin. But when the chondroblast cells get to mature into chondrocytes and are now actively producing ECM, all right, they get to be pushed away from each other, and now resulting in each occupying a separate lacunae. Important also to note is that all hyaline cartilage is surrounded by a perichondrium, except that hyaline cartilage at the joints which form an articular cartilage, like that diagram that we saw earlier. The perichondrium is there simply surrounding it because it supports the cartilage with the nutrients and the O2, for it is vascular and the cartilage is avascular. So the cartilage now receives nutrients and the O2 through diffusion of nutrients and O2 from the perichondrium. The perichondrium is also there surrounding the cartilage to maintain its growth. All right, so the perichondrium actually has got two layers. So at all synovial joints, we find hyaline cartilage. You know, we can talk of the knee joint, you can talk of the hip joints, all right, you name them. Hyaline cartilage in the human body is also found, existing in the walls of larger respiratory passages, like the nose. All right, look at that skeleton there at the nose. That's where we have our cartilage found, on our nose there. We also find it in the larynx, all right, making up part of the larynx. Look at that lung there on the larynx is made up actually of hyaline cartilage. We also find this hyaline cartilage in the trachea. Now, those rings of the trachea is actually hyaline cartilage, all right. Also the bronchial tree there at the lungs, you are seeing that bluish color is actually the hyaline cartilage. All right, we also find this hyaline cartilage in the ventral ends of ribs on our thoracic cage, all right, where they articulate with the sternum. We also find it actually in the epiphyseal plate, of those long bones, all right, where it makes possible longitudinal bone growth, right, which actually helps us to even increase in length actually, all right. So it is almost all over. No wonder it is so abundant. And the main function actually of this cartilage is to provide smooth and even a low friction surface in joints. It also supports, gives a structural support to the respiratory tract, to all those airways of our respiratory tract. They are structurally supported so that they should not collapse. They are structurally supported by those rings actually, which are but hyaline cartilage. Wow, what a fascinating kind of cartilage. In summary, It is so fascinating, friends, to note that hyaline cartilage is the most common cartilage in the human body. It is also so fascinating, very fascinating, to note that its extracellular matrix is homogeneous, has type 2 collagen, and aggregate is the most abundant proteoglycan in but the ECM of the hyaline cartilage. It is also so fascinating to note that the major cells in hyaline cartilage are chondroblasts, cells and chondrocytes. It is very fascinating also to note that hyaline cartilage is covered by perichondrium, except at epiphyses and articular cartilage. Very fascinating also, friends, to note that in the human body, this hyaline cartilage is found in many components of the respiratory tract, even at articular ends and even at our epiphyseal plate of long bones. And it makes the fetal skeleton. Very fascinating to note that if it degenerates, friends, you may have osteoarthritis. Very fascinating also it is that you must join us again in the next episode when we'll be talking now about the elastic cartilage and the fibrocartilage. For now, it is bye-bye. But as we age, there is a gradual change in the physical properties of the hyaline cartilage that lines the articular ends of bones in joints. And this is a characteristic of osteoarthritis. In other words, the aged are prone to osteoarthritis. That is a clinical condition. So as we age, we get susceptible to osteoarthritis, which is simply has to do with hyaline cartilage degeneration. And the areas that are prone to osteoarthritis are those joints that are weight-bearing, like the waist and also the knee joint. And also, this suggests that people who are obese, people of too much weight, those who have much of weight, those who are fat, for example, are prone to osteoarthritis of the waist and even of the knee joint. And also joints that are heavily used are prone to cartilage degeneration, right? Like the wrist and even the fingers.